I'm Dr. Walck, your assistant professor at Embry-Riddle Aeronautical University, and I am here with our winning RobotX team. Okay, tell me or give me a description of the competition and what set you guys above the rest.
So the Maritime Challenge RobotX competition is a competition where different teams must build autonomous surface vessels. This means that each team has to integrate and have hardware and software to accomplish or complete different autonomous tasks. Our team was set itself aside from the rest by bringing the most innovations in terms of hardware and software. We had some of the most unique sensors in the competition, and we had really good software tools to get our boat across the different challenges.
Can you describe some of those innovations to me?
You want to talk about sensors?
Okay, sure.
Yeah.
Yeah, I think one of the biggest things from my end that I think are big innovations for us is just the amount of, I was told I overused the word robust.
It's alright, we can use it now.
But we have a lot of robust sensors.
Okay.
The thing I really talked about a lot was our robust sensing suite. So we have a new sensor suite with 6 cameras and 3 front-facing high point cloud density LiDAR. And so using those sensors, we're able to get really high fidelity information about the area in front of us, and that helps us really to perform well in different tasks, being able to collect the data.
So this word intrigues me. So robust. Why does your system need to be robust?
Yeah, so when we're out on the water all day, we really need to rely on those sensors being up and running at all times. We can't be constantly needing to pull the boat back to the dock to restart the sensors or restart the computers. We really need to make sure that our sensors are reliable and working.
And what type of environment are you guys actually testing in, or you guys came back from Australia, was the competition in? Are you always competing in Australia? Are you always testing in Australia, or environments changing?
So it's a biannual competition. So every 2 years the competition goes to a new place. In the past it has been Australia, Singapore. This year was the first time they hosted it in Australia. We went to Penrith, an international Sydney regatta. The environments we face, they're all maritime, so sometimes we are in Daytona, we are out here in the river. You can get anything from rain, fog, really sunny days, and each day can affect your sensors differently, especially cameras. They have issues dealing with all of those different weather conditions.
Okay, do you guys have different software packages that deal with them, that kind of change how your sensors react, or how do you deal with all of these changing environments?
So I think the big thing is just having different sensing modalities, not necessarily changing the software based on the occasion, but being able to have access to sensors that have different capabilities and different strong points. Like we have 4K cameras, which are really good for getting high resolution imagery, and we have high dynamic range cameras, which are really good for getting you better color information. So like they serve different purposes, right? Whether you're trying to resolve something or whether you're trying to be able to tell what something actually looks like to the eye. And then we also have infrared thermal cameras, which can be really useful if there's fog or it's dark out or it's rainy or something. They kind of ignore all of the effects.
Okay, so this is biannual. So how do you prep for each time you do it?
So I guess I'll take that one. So what we do is we take basically a 2-year design cycle. Every 2 years we're redesigning the boat, we're redesigning the software suite, but we spend most of the first year and a half really working on tools. And then the last 6 months or so we're trying to bring those tools together to accomplish whatever the tasks are that the competition has set out for us.
Go a little bit more in depth for our audience of what do you mean by tools? Like something I'm gonna, like a wrench?
No,
or
so
a tool package?
the tools I'm talking about are specifically hardware or software solutions for the boat. So in the hardware, what are your propulsion systems? What are your subsystems that are going to provide manipulation with the real physical environment? So the competition requires you to do aspects of launching a drone this year and flinging a racquetball at one of the targets. And so you have to build equipment for those things. But then also you have the software tools, which are aspects of navigation. How am I going to navigate my environment safely? Aspects of how am I going to perceive my environment safely? And then how do I accomplish the task, knowing that I'm going to look for specific elements in order to accomplish those tasks.
Okay, so you have this boat that goes onto the water, and then you also have a drone that's paired with it. Is the drone throwing this object at something? What is the projectile? What is going on? I'm trying to lay out the scene here. We have a boat, a drone, and something throwing.
Yeah, so there's actually supposed to be a ball shooter attached to your system that would not be attached to your drone because
Okay.
the drone needs to be able to leave the system by itself autonomously and go do other tasks unrelated. So yeah, you're supposed to design a turret, if you will, that can track the hole that it's supposed to be shooting the ball into according to whatever size that they set up for that year's competition.
Okay, so that's attached to the boat.
Yep.
What is the drone doing?
So the drone, the specific task for the drone, we were interested in the cooperation between two vehicles, and so the main task for the drone was to take off autonomously from the boat, and then it was optional to land back on the boat autonomously, but it was mostly there as an additional sensing modality, so it was supposed to be able to take off from the boat and survey the environment and provide additional environmental information to the boat. This year, we focused primarily on getting it to launch autonomously, and then it was designed to return to the shore safely.
And to be clear, we actually did not do the ball shooter this year. We pulled that out of our requirements to focus on the other aspects.
That was kind of my next question. You guys have these tools that you've been working on for, what, a year and a half, getting ready for competition. You're finally at competition. You don't actually get to bring your packages in this nice travel, right? You have to take it all apart, box it, and ship it to wherever this is located. Tell me a little bit about the feeling behind that, and then what happens when you actually get there. Oh, stay tuned to find out the team's feelings, plus the best and the worst moments of competition in our podcast part 2. We're going to air Monday the 5th.